All right, hello everyone. Welcome back to our regular programming, the ClusterDuck paired programming stream. It's been a while, but we are back, and today we're here with Rory. So you can say hi.
Oh, hello. How's it going,
You get
everybody?
the big head on the screen. Um, and today we're going to be going over the work that he's been doing on two-way. So, for a quick recap, currently in the CDP, the cluster duck protocol, messages can only go one way from a mama duck to a papa duck, which then goes to the internet. There's no way for a mama duck to know if the message it sent was ever received. So what Rory has been working on has been building in a protocol for how to handle message acknowledgments. So Rory, why don't we jump into that, and why don't you share your screen and kind of just give us a little demonstration about how the two-way works.
Yeah, sure. So right now what I've implemented is basically Mamaduck here on this console is sending out messages. I think it's once every 60 seconds or something like that. And then the Papa Duck receives those messages. This is the Papa Duck over here. And then Mama Duck receives the ACK that the Papa sends back. So that looks like something like this in the output here.
And ACK means acknowledgement.
Correct, yeah.
The acknowledgement that the message was received.
Mm-hmm. Yep. So, yeah, what would be interesting for you to look at here, Nick?
So maybe do you want to show on the Papa Duck a little bit how when it receives a message, what it does?
Sure, yeah. So, um, I mean, you can see just a little bit here of what it goes into the terminal
So
output.
yeah, so start. So you can see here. So it goes handle receive packet, right?
Mhm.
If you want to just highlight that, yeah. So right there. So it starts that. Okay. So it says the packet length, and then it outputs RX packet, which is the with the it's all the data in hex,
That's
or
correct, yeah.
in the byte form,
Yeah,
and yeah.
actually, this is maybe something I should comment on here. RX packet here should just, yeah, this is the hex version and this is the ASCII version.
Mm-hmm.
But since all of the characters beyond the source um, the source DUID, the source duck ID is just not really doesn't really convert to ASCII. So all of this this happens to be the rest of the packet, and this says Mama Duck in hex. I promise. So um, so yeah, that's what it's doing here. It's only receiving one packet, but it's printing it out twice.
Then the next line, it's checking the CRC just to make sure that nothing was corrupted while it was over the air. So we do a little, what CRC basically does is it does runs a little algorithm on the data and then outputs a number. And when that algorithm is run again, we can compare to see if the two numbers are the same, and therefore that means nothing is changed. Then we can see the RSSI, SNR, and this is just all the data about the signal strength and also the signal. So okay, so the next part, prepare for relaying. Um, so let's see. Is it doing? I don't think is it relaying. So what's happening right here?
So this is I kind of just hacked together a little bit what the mama was doing to get
Mm-hmm.
it to do a similar thing on the papa. So
Mm-hmm.
basically, what prepare for relaying is doing is it's checking if it's seen this packet before, and if not, it's invoking a callback in the application.
Mm-hmm.
And I can show you that in a minute. But
Mm-hmm.
so basically, what happens is the relaying code will, in this version, I know we have a Bloom filter version on the way that'll do something different, but in this version, the relaying code adds Papa Duck to the end in the path section, which is going to be something like around here. I don't know. I think if I recognize it correctly, like it's something there. So anyway, it passes that on to the application, which just prints it out, just using the same kind of function that the mama example code uses. So that's the counter 12 message there. And I can show you that in the mama console output if you'd like, where it's the counter 12 is coming from. So let's, I guess, look for that real quick. Where are we at here? Counter 15, 14, 13, and 12. So this is where the mama originally sent that packet. And the interesting thing here is the MUID, which is 9560. And of course, you can see the Papa sees the same thing for the MUID 9560. So
yeah, and then you can see here publish failed. That's because it's trying to publish the internet, but it's not connected to the internet, so it puts it into a queue. So
correct. Yeah, I just haven't been worrying about publishing to the internet for this for right now.
So that's fine.
Kind of a separate problem, but yeah. So then the interesting thing here is that you can see Papa Duck sends the ACK to the Mama Duck. That's the same DUID that we saw and the same MUID that we saw. And yeah, so then back in the Mama Duck, we can see when the Mama Duck is done, kind of like sending a bunch of stuff.
All right. So
well,
yeah. So the
yeah. Sorry. Here, I think I.
Yeah. So that is the that message right there is the what you call it the ACK package. Yeah, because you can see right here because you can. So actually, I'm looking at the bytes and you can see the 4D 414D right there. That's the mama component, and then after that the 30 the 30 30 30, that's like the 00, I think. And then you have the Papa, which I forget what that one is. Somewhere right there.
Yeah, it might be the 41 50 41, or 51 41. Yeah, whatever.
Yeah, something like that. Yeah. So, it's definitely the 41s. Yeah. So, not that anyone needs to memorize byte code or anything like that, but so this is the message that has been received from the Papa Duck, which we've never done before. So we can see, okay, it's received a packet, it's checking our CRC like it did before, and then it's doing the relay, and then so it's saying like, have I seen this before? So how does it figure out if it's seen it before? Because if you're just adding to the path, it should say in the path its own ID. So how do you get around that? So it normally it would throw out the message because it sees inside the path that it has the same ID.
Okay, so actually, that's maybe the interesting thing about this is that the path component is actually only this, and I mean it's very perceptive of you to notice that it's got the Mama Duck being the, what is it, the 4D 14, like, yeah, that says Mama Duck in ASCII right there. 0 0 0 1 actually,
and 3 1 is the one.
So yeah, somewhere in there it says Mama Duck. But this is actually the data component of the packet. So I can show you this in code and it'll look a little bit clearer to people who aren't just like reading, converting ASCII. Yeah. But actually the data component, I think I can highlight just about all of it. And hopefully I'm not messing it up. But this is the section there, which is all the data. So
Mm.
what it is it's saying 1 as just some number, and then it's saying the ID of the duck that is getting act, and then the I presume this is the somewhere around here anyway. I think that is the 8 bytes that is saying what the MUID is. So
Oh yeah, actually you can confirm that if you look further up, you can see the 9.5 for the MUID. So the MUID converts in byte is, so you can see right here with where my cursor is, it's 39353630, and I think that is what you have there.
Okay, I can't see quite on your screen.
Oh, it's right here. The where you have when you sent the message before it, you actually have in the MUID right there. Yes, exactly.
That's right. Yes, thank you.
Yeah, and that's what you have after the 4D41, and yes, that's what you have, the 353630. Okay, yeah, right there.
Yeah,
got it.
Cool. Good team.
So do you use the destination? So there is a component, so you'll actually see in the RX packet there's a bunch of Fs towards the beginning. So that was usually reserved for the destination duck. So you're not using that component.
I am using a new destination.
Okay.
And I am going to just stumble around until I find it. Actually, I should probably just search for it. Maybe this? Nope. Give me a second here. What's the library file called? It's we don't want to look in libraries, so I'm going to do minus libraries. And oh, great. Okay. Yeah, I know where this is though. I can find it's not too slowly, hopefully. PapaDuck should be using this. Broadcast ACK. Broadcast BUID. Okay. Well, that's fine. That's fine. I need to specify source. You know what? It's got to be in here somewhere.
Is it? Do you have it in the CDP CFG, or in the
duck packet? Yeah, it's where the 0 DUID is defined. So okay, but here it is. So yeah, this is what I've added here is the broadcast DUID. So that's something that I was using to just kind of indicate that every duck should get this packet, whereas I thought that semantically 0 DUID kind of meant the Papa, the upstream connected Papa.
Okay. So you're using it as almost like a type.
I'm using it as like a message. I'd say I'm using it as a destination, as a broadcast as being the destination. Yeah, because and just to back up a little bit, you can add ducks to the network, to the mesh, and they won't know the address of the PapaDuck. So what they do is they just fill in this 0 DUID, and that's just how the mesh kind of gets up and running. And I figured, well, the PapaDuck also doesn't need to know the actual address of everything that's going to go into that broadcast packet.
So this is in preparation if you were to do so. Okay, so here's me kind of how I was originally thinking about it. So if you're sending one ACK at a time, right? It would make sense to put, instead of the broadcast device, DUID, it probably makes sense to put in, because the sender, because you received it, it has the sender in the message. You can put that into the destination. But if we're to help save on traffic, now that's if you have a if you do that, the amount of traffic you're creating is 1-to-1, right? You generate as much traffic as as many number of messages that you send, which is not great, because especially in a mesh network where when you send one message, it exponentially grows because every single device is sending the same message as it propagates. So
That's
what
correct.
you could then what I'm seeing here is that your intent is that you'll send it as a batch. So you'll say not just one sender in there, maybe you have 10. So now you're 1 to 0.1. So you're not generating as many messages for acknowledgement.
Yeah, that's correct. So exactly, yeah, we're just trying to batch together everything. Like, obviously, with the case that I just showed you in the console here, it doesn't make a lot of sense. But yeah, when we are batching together multiple acts, we can fit together currently 14, and that number will increase when we have the Bloom filter implemented and merged in.
Okay.
But yeah, so I mean, while we're on the topic, I mean, this is the kind of like the protocol here, is that like we've got the data section consists of n, which is just the number of acts basically, and then just repeated DUIDs and MUIDs until we fill up basically the rest of the path, or sorry, the rest of the data component.
Yeah, and then and then I see the math that you did here below, where you can calculate that you can fit up to 14 at once, which is pretty nice. Now, is there anything currently or you planned in the future, if let's say one of these ducks has just been very chatty, and let's say 10 of the 14 messages are actually from the same duck? Is there any plan to save space because if you're writing the same DUID every single time, right? If we're going to send all these at this batch to basically one device, right? Is it potential maybe we can save some space by only having one, just doing it the duck ID once, because the duck ID is 8 bytes versus and so if you had to do that every single time.
So the quick answer is I assumed that wouldn't be a good duck citizen on our mesh network if that one duck is just sending tons and tons of messages. Although that could be appropriate for like bursty communication if one duck needs to communicate like 10 things all at once, and that's just the nature of the network. But yeah, currently I don't have anything in place to do that. If we did want to save space doing that, there's kind of like two options. I think one would be getting the DUID to be shorter, and that could fit in with this same scheme here. And of course, the other option would be to have like number DUID, number DUID, kind of repeated over and over. I mean, those would be the options. And of course, you could use like the length of the data component, which I think is, I think the length of the data component is communicated somewhere. The length of the packet has to be communicated anyway. So
yeah. So then also, I guess now I'm thinking about it, you'd also have to communicate how many how many message IDs should it be looking for once it sees its name.
Yeah. Yep. Exactly.
Um, yeah. So also, I don't know how. So how do you? So may I ask a question? So how do you search for? So if I'm a duck, how do I search for my uh, device ID? Am I looking to say like, hey, does mine exist, or are you searching blocks?
Um.
Just because,
So.
so the reason why I ask is because if it's just saying like, hey, in a bit stream, right, or whatever, there's a whole, does my sequence exist? I mean, you could potentially have a mix between like part of a let's say message ID and part and half of a uh, device ID put together could form a mama duck. I guess it wouldn't matter because the following part. Do you see where I'm going with this? Where the following part wouldn't match anything. So I'm just saying, like, is there how you're searching? Is there potential where it would get confused and think, oh, this is for me when it's actually not in there?
Um. Well. It shouldn't. This is at a high level. This is what it does. It basically checks if the topic is ACK. If so, then it handles ACK, which
Mm-hmm.
assuming that's magic and works in a way that doesn't get the wrong ACK, we're good. And of course, hopefully it doesn't. This is something that I would have liked to unit test, but we don't have any unit tests kind of like set up on the project. So
Mm-hmm.
I decided against trying to add in any sort of like unit testing framework. But to your point, that's something to be cautious of. The way that I'm handling it right now is that I basically will check like the number of uh, pairs that have been specified. Let me
Mm.
just actually bring
Okay,
up.
so how you do it actually addresses that issue then. If you are separating it into pairs, all
Mhm.
right. So the data has already been separated. So here are all the available pairs, and then you just search within there. Then it should
Yeah,
be impossible for it to because you're only going to be looking at the first 8 of each pair, right? To see if that's
that.
mine.
Yep, that's right.
Mm-hmm.
And it's like, yeah, if that first 8 bytes are the DUID that is my DUID, then yeah, I will continue looking to see if the
Mm-hmm.
MUID is the MUID that I'm looking for,
Mm-hmm.
which is that MUID right there, the
Mm-hmm.
last message MUID. Yep.
Yeah. So you do want to yeah, so I think what you said addresses my question. So do you want to just go through line by line and just kind of just go through and explain what's happening for
Yeah,
this?
sure. Sure. Um, so let's see. Starting out, we have it's got a little bit nested here, um, but we have duck utils. So we're saying if the DUID of the packet is our DUID, or else if the DUID is the broadcast ID, we're going to handle it. We're going
Mm-hmm.
to look into it. um, and yeah, just to explain, I thought maybe in the future we could use the DUID when it's like sending every ACK to a single device. So you know, this is maybe unnecessary code right here. Maybe I should just get rid of what I've highlighted, but I figured why not? Like
Yeah, it
it's
shouldn't
pretty
be an
easy.
issue. Yeah.
Yeah. So from then I check to make sure that we were actually looking for a last message MUID. Potentially you could have multiple ducks on the network that have the same DUID as us. That shouldn't happen, but theoretically that could happen. Or else, if the broadcast uh, packet or the broadcast address has been specified, then we'll enter into here. But we want to make sure that we are, actually looking for some MUID, and we're not just like going to look at some garbage initialized value inside of last message MUID. So, this just indicates that last message MUID has been initialized. So from there, we will look at the first byte of the data. So, it's got the number of pairs from that, and number of pairs length. What did I do there? Right, that's just the length of that byte there. So I'm just using kind of like constants to indicate stuff later on here. We'll come back to these constants as we hit them, but we just from here we just iterate through each pair of DUID MUID, and what we're doing is we're getting the offset for that pair, and then we are using that offset to get the DUID offset and the MUID offset, and make this a little wider here. And from there, we're just comparing. We're getting the DUID and the MUID from the packet data, and we are comparing. Is the DUID that we just got equal to our DUID, and is the MUID that we just got equal to the MUID that we were just looking at? And like there's some other stuff in here, like the pair length is always going to be the size of the DUID length plus the MUID length, and so we kind of just iterate through to get the pair offset via that. So that's a bunch of stuff, just like.
So the num pairs length is always going to be 1. Is that the number that you put at the very beginning? Was that what the?
Yeah, exactly. That's number
that
over there.
Right there. Yeah.
And then each pair is those two.
Afterwards. Yeah, got it.
Yep. Cool. Okay, having scroll troubles here. What is happening? Okay, whatever. I don't know what's happening with my ability to scroll right now. What? Hold on. Okay, my mouse is freaking out. My mouse just does that sometimes. Okay. So anyway,
right.
Does that make sense on all of how I? Yep.
That makes sense. That's awesome. So I'm assuming it's not in there right now, but if I were to send a second message, would it overwrite the last message MUID if I did that before I got the ACK?
Yeah, so I mean, I think that's a little bit of a separate question. There's overlap here, certainly. But yeah, MamaDuck could track as many MUIDs as you want to. MamaDuck could use like different schemes for doing that, like one MUID per topic or 5 MUIDs per topic, whatever's appropriate to, I don't know, the application or to the protocol. I'm not really sure. And that's something where like I see opportunity to make things better there. What I've done is just kind of some like placeholder, single last message MUID.
Yeah, exactly. And that's there's always going to be infinitely improvements that we can make, and so that's just something I just wanted to put out there as part of the discussion. That's something like would be a next step. Once we get this, because this hasn't been committed yet. But I think would be the next step, where we can say, okay, now how can we handle more messages? And I think this would be a good point, if anyone who's watching is interesting to add. Oh, Charlie, speaking of people, hello, Charlie.
We have Charlie.
Yeah, we have a wild Charlie in the stream. Thanks for joining, man. But anyways, but yeah, so that's something that we, we can work on once we get this component out. So that's great. So what other components did you add to get this to work? This is definitely probably one of the main ones.
Yeah. So I mean, there's a couple of interesting spots in code. We could look at the Papaduck
Yeah.
like equivalent version
Yeah,
here.
why don't we look at the Papa Duck?
So yeah, jumping there now, we've got handle received packet, which is the best and most greatest function ever.
The one that's used so much.
Yeah, it is. Yeah, it's very important. So I think my changes start in and exist in this highlighted section here. So yeah, basically, we check if we need an ACK. We maybe, we check if an ACK is needed. Then we set an ACK timer. I'll get to the ACK timer in a minute. But basically, we store the ACK for later. And then we check if the ACK buffer is full. We will broadcast the ACK. Also, in the ACK handler, we will broadcast the ACK. So yeah, that's the scheme of things, is that we will broadcast an ACK if we're full of ACKs or if the timeout has been reached.
Do you want to just jump into store for ACK?
Oh yeah, sure. So store for ACK is pretty simple. It's just this ACK store. We just push back this pair.
Okay.
And let me just bring up the ACK store and the other related variables here, the member variables. So yeah, ACK store is basically, it's just a vector of pairs of DUIDs and MUIDs. So I've just created this type def for it just to make typing a little bit easier. We can see that I haven't actually used that type anywhere, so I guess I was thinking there would be like an iterator that would use that, but I don't know. At least we've got the type def for convenience later.
Well, it's something that we can use later. Actually, no. I was thinking from the Mama Duck, because it was what I was talking about earlier, is where you need like a dictionary or something like this where you're storing messages, but this is a little different.
Yeah, I kind of just went with a pretty bare bones approach, and you'll have to forgive me for just like stumbling through things here. It's been a couple of weeks since I've looked at this. So yeah, that is the ACK store, and I can just show you that, like, briefly, broadcast ACK also uses the ACK store. So, and the ACK buffer is full function also checks that. So, that's kind of the lowdown on ACK store. Do you want to see the timer code?
Yeah, sure. Yeah, let's look at the timer.
Okay, yeah, I think the timer code is a little bit less obvious. So, first of all, timer is going to start out being empty. So the first time this code comes through here, it's going to see that it's empty, meaning that there's no function set to be called. When it is, when code enters this section, we will set a timer, which is, right now, it's just 1 second, which we need to make longer to have any reasonable chance of getting other acts in for the broadcast. But I just sent this like this so I could test things quickly. But yeah, so timer delay here is timer delay here. And we pass in our handler, and we pass in the Papaduck as a parameter. So the thing about the timer code, this is just the Arduino, what is it, the Arduino timer?
Yeah.
I forget where that comes from exactly, but
yeah, it's the timer that we've found to work for us pretty well.
Yeah, works good. So yeah, ACK timer gets past this ACK handler, which of course is static. So that's why we're passing in the Papaduck pointer. And that, here it is on the implementation side. PapaDuck gets passed in, and then on that pointer we just call broadcast ACK, and then we return false to indicate that we don't need to do anything else after that, because we're relying on other code to set up the timer again.
Mm-hmm. Okay, so that's interesting how you do that with using using the PapaDuck object.
Mm-hmm.
That's pretty cool.
Yeah. And so of course that's kind of like the two ways to get to broadcast ACK is through the ACK buffer being full and through the ACK timer firing off.
Mm-hmm.
And of course, broadcast ACK now is where the magic is at. So basically what happens is that we're just asserting that the ACK store isn't over the size limit, and we're just crashing if it is with some kind of like reasonable error message, because that's just an invariant that I was assuming. So from there, we get the size of the ACK store. We what do? We push back that one that size as 1 byte. That is, of course, this n over here. And then basically for each of those pairs, we will just push back. We'll just get like the ACK store's DUID and MUID that is on that pair. And then we'll just push those back into the data payload. And that just forms a bunch of DUID, MUID pairs.
Mm-hmm.
And then, so, after that, we send out we prepare the packet for the broadcast DUID, and, we pass in data payload there. So this TX packet gets created fully, and then we tell Duck Radio to send off our packet. And of course, lastly, we need to clear the ACK store. So, that kind of wraps it up for what broadcast ACK does. How does that look?
No, it's good.
Cool.
Mm-hmm.
Nice. So, yeah, is there questions that you have on this? Or I can also go on to talking about other things as well.
Yeah, no, I don't think I have any questions on this. It looks good.
Cool. All right.
Mm-hmm. And this is what you were showing us before in the serial was this component.
Yep.
Yeah. You can see in the logs.
Yep. Sending ACK to DUID. It'll bring up PapaDuck's thing. Sending ACK to DUID.
Right there. So. Mm-hmm. Yeah.
Yeah.
Mm-hmm. Love the logging that we got going on.
Yeah.
All right. So so is there any other components that you feel that we should talk about?
Well, right. So the thing about this, all that I've done here on the back end, is that it's not particularly useful to any users right now. So what I wanted to do before actually submitting this PR and calling it, mergeable, is that I wanted to implement something useful to users. So what I did was I tried to get the captive portal to basically show the MUID of the sent packet, and then to just query the MamaDuck to figure out whether or not that MUID had been ACKed by the Papa. So I can talk about that. That code is a little bit more just entirely new.
Yeah, why don't we go into that, because I think this is also something that will be interesting, because this is, I think, is also a bit of a gateway of using a captive portal and updating the captive portal with real-time data. I think is definitely a little bit of maybe a breakthrough in the sense of what other stuff we can do.
Yeah. By the way, this front end code is really fun. It's a little bit like crazy to try and look at here, but it's a lot of fun. So what I'm gonna do is just copy all of this out of here, and then copy it into a new. Oh great! Oh no, it didn't get the right syntax. So I'm gonna apply JavaScript syntax so we can see just a little bit easier. So like this is the code that gets served to the front end. And there's like a couple of things that it does. I wish I had thought a little bit more about how to begin sharing this with you. But I mean, we might as well start with the initialize function, right?
Yeah.
So yeah, but what initialize does is it basically checks if storage is available. And this is just some code that I found on the MDN network. And it's, it tries to use the storage, and if it fails, then it will return basically false. So that's important. There's some additional things that fall into the scope of looking at with you another day, Nick. But that basically allows us to figure out like, okay, if we can use the local storage, then we can basically generate our client ID or else get the client ID. So that's what this code is doing here. It's saying if we have a client ID stored in the local storage, we'll get that, else we'll generate our client ID and store it. From there, we will update the client ID in the DOM, and then we'll kind of like set up some listener for the send button. So that that's going to do some AJAX to like send off any kind of message that the user sends. So like if the user sends off some kind of like help message or something like that. I think actually I can bring in. Oh, Chrome seems to have frozen. Nope. Wait, I got it. I'll bring in a screenshot so people can see what I'm talking about. So yeah, basically, this is an old version, but this is sort of what it's going to look like. So this is the client ID getting updated, and then this is the message that they can send. And the listener that I just mentioned is listening to this send button. Yeah, stop me if anything's needing more explanation, but basically, yeah, that's what's going on. We're waiting for a click on that send button, and that's going to trigger this this thing that I've kind of like wrapped some functionality into a controller, is what I'm calling it. And
so okay, so let's see. So send message. All right, and this is sending the message that that was put in the text box.
Yeah, that's right. It gets the input from that text box, like 2 ways on the way sort of thing here. And it will.
And then I see you have here a save last MUID.
Yeah, that is correct. We will put that last MUID into the DOM.
And so, yeah, go ahead. Sorry.
Yeah, and we will also create this MUID request. So that is this other kind of like object that is basically just, all right, this is just a wrapper, like sort of factory function that wraps around this MUID request object. JavaScript is weird, but perhaps this object, which basically will kind of do the right thing until an ACK or an error happens, if I remember correctly. Or no, actually, if there's an error that happens, it'll keep on requesting the MUID status. So,
So why don't you go through here? Why don't you go through each of these ones? Show status, load listener, all these ones, and just go through how they work.
Cool. Yeah. Show status, pretty short and sweet. Basically, that is just used to update the status and the message, which, bringing back our screenshot here, our status, I think, is act, and our message is message acknowledged, just to give you a feel for what that's going to look like. And yeah, so there's a couple of different ways that the status can get updated. Like, we can have not act, or we can have an error. So instead of saying act and message acknowledged, it might say error, there was an unknown error, or something like that. And so yeah, like, this is all a little bit of a placeholder sort of setup that I've got going here. Like, these words, I think we might want to fiddle around with them. We might want to display some like big red box, whatever. But yeah, I just wanted to get something going. So, apologies to anyone that's watching that's like a front-end engineer.
And
anyway.
If you are a front-end engineer, you know how to make this better. Definitely join us on Slack. You can find it on ClusterDuckProtocol.org or from project-owl.com. You can join us on Slack or on our GitHub. You can look for us, ClusterDuck Protocol, and contribute. So it is open source. This is open to everyone. So put a little plug in there.
And it's fun. It's fun to work on. You're doing something good.
We have a wonderful community from around the world. So definitely join us.
Yep. So yeah, just to kind of finish up showing some of what show status is all about. We're adding in the status and the message here from the res, which is just the result of getting some response from the server. And the server in this case is DuckNet. And I'll just show you kind of briefly that this is the status function here, where this is where we're getting the act status from, and the message is coming from here. So just to let me see. Yeah, so we create the response, and this is in our MUID status.json endpoint. So that's what gets passed back, and I just wanted to kind of like follow through showing like what it looks like from the server side. Yeah, so, and of course, yeah, so that's maybe a decent lead into talking about this load listener, which that gets called when the DuckNet has responded. So in the optimal situation, it'll say like act message acknowledged, and this won't happen, and we'll just update the thing. But if not, we might have the error listener might happen. I'm explaining this backwards. Let me back up here. So what really happens first is that the request MUID status happens. That creates a AJAX request right here, which has the event listeners on some events, load and error. Of course, we're passing in the MUID URL, which is just going to be what we saw earlier here. It's this MUID status.json. And some parameters. Let's see. what's interesting about this, we create the parameters and like append those to the open call or this request. And one interesting thing is that make URL unique is good for ensuring that the browser doesn't cache each request. I'm not a front-end engineer. I just kind of like looked this up. So what it does is it basically just gets the new date and time. So, you know, in that way, every request will be unique. And so therefore the browser will say, yeah, I need to pass this on. So anyway, that request gets sent. And then basically we're just listening for the load listener, which is this guy, and the error listener, which is this guy. And yeah, the load listener, like, as I was kind of saying earlier, it will have some response text stored in the XML HTTP request object, and it will just parse that out. Since it's a JSON endpoint, that's why we use JSON.parse. And now it's a JSON object, and we can just, pass it along as needed. So, that's kind of a lot of stuff if you're not commonly looking at Ajax. But yeah, how does that look to you, Nick?
No, it looks good. This is great, and I think this is also is a good. I think would be kind of a. I kind of just thinking about how the next step of how we could use this as a template for getting other things. So like, let's say I have a sensor on my duck, and I want to get the data from it and be able to see it on the captive portal. This would be how you would do that. You would be able to basically use this very similar system to be able to do that, and I think that has a lot of implications. I'm also even thinking from a developer standpoint to have basically turn this into a developer console, right? Being able to maybe even get almost like a serial output potentially, maybe, or something like this, being able to be able to see what the incoming messages and get all these kind of debug stuff and be able to see it on your phone and not have to be connected to a computer every single time, or be able to get logs and stuff like this. So I think what you've done here has a lot of that implication that you'd be able to do a lot without needing to necessarily develop another app to do this. So
yeah, the Ajax stuff is super cool. It kind of turns the page into like a little bit of a single page application.
Yeah.
It's just like the smallest single page application ever, but it's fun.
Yeah, no, and it's just, I think there's a lot of implication in what you've done here on this part. So that's awesome. Yeah, so we don't have too much time left, but I think maybe it would be good to just kind of quickly go over, what are, there's some things that are, maybe you want to change so that we can merge it in. Is there anything you want to talk about for that, or?
Yes. So Duck Radio is the thing where I ended up writing some platform-specific code. I believe it's in here. Yeah, here it is. So this is just context switching here. There are interrupts that happen on any particular platform, like whether it's a Heltec or a Pi Micro or whatever. And those interrupts are going to indicate to us, to the ClusterDuck protocol library, when a packet has been received. Also when a packet has finished being sent, or other sorts of things like errors where the LoRa protocol has had a CRC error or something of that effect. Yeah, it's kind of anything that the hardware wants to tell us. That's when we can get interrupts. So I was looking at the code that existed here previously, and it was centered around only expecting whatever was relevant to the particular device type. So if it was like a PapaDuck, I don't think it particularly cared about the interrupts, other than to like update maybe when the packet had been sent, when a packet had been received. Actually, I've got that backwards. PapaDuck would care because PapaDuck would see packets arriving.
Also, well, now it's going to be also sending stuff too.
Exactly, yeah. And MamaDuck wouldn't care about packets arriving. MamaDuck wouldn't be listening really for the interrupts so much at all. Not in a way that I think really mattered. It's been a while since I've looked at this, but so anyway, what I needed to do in order to get my ACK stuff working was to basically get the duck radio to care about both sends and receives, because interrupts happen when a packet is sent. So it kind of needed a way to differentiate a packet being sent and that interrupt happening from a packet being received, because now both can happen in both the Papa and the Mama. So I went overboard and found like the particular platform flags that are getting used by the Heltex that I'm using. That's this SX127X. I don't know why that's the name, but that's what the Heltex are in the RadioLib library. So long story short, this will not work on other devices, and I'm not sure which ones, but this is the code where I need to basically say, like, I think what I can do is track whether a send just happened, and if so, then I can mark things off accordingly. So I can say, okay, we just sent a packet, and we have the interrupt happening, so that means that we're receiving a packet instead of the send happening, and vice versa when we haven't just sent a packet, or you know what I mean. So yeah, that's basically what I need to do. I think I can just work on that probably tomorrow or something like that, and let you know how it goes, unless anybody wants to pair with me on that. But the alternative would be to abstract this stuff into some separate like polymorphic object, which will basically call things like set receive true and the set the receive flag.
We can definitely work on that. But this is really great. Amazing work. So really excited to get this in. I mean, I think that I wonder if if that is like a real hard stop from merging, if we can. So I think we should look into see if it as it is already can merge and then fix that. One other component, maybe something to think about, is being able to set a way where you can turn on and off ACK. So not because right now, most systems aren't looking for an ACK or anything like this. So I think there might be something where, like, hey, we don't want to use that, or let's say we have very high traffic and we want to limit it and just kind of take our chances, right, where not every single message needs to go through, but we don't want to generate that more traffic with the PapaDuck having to send stuff. So so the thing, something also put in there is there's a way that we can toggle that where on the INO level you can say, hey, I want this duck to look for acknowledgments.
Yeah.
That's something just to think about as well. I think we should definitely put in there. But this is really awesome work. I think that's all the time we have for today. So thank you again, Rory. Really awesome having you here. And also the work that you've done has been amazing. Really excited. And also Rory does a lot of his own pair programming sessions, so definitely join us in Slack. And if you want to talk to him, yes, it includes you, TerraCore. And so then you can join through there. So he posts links for the Discord server that he uses for that. So anyways, I think we're going to call it for today, and join us next week for our next stream, where we're going to be doing a little focusing on how to set up your own Duck network. So just kind of a getting started type of stream. I think we're going to be looking to do that next week, Tuesday. All right. Thank you, Rory, and everyone have a nice rest of your week.
Thanks, Nick. See you later.